Impulse. Impulse is a change in momentum caused by a force applied over time. And remember, a change in momentum, we can use the delta triangle to symbolize the change, and momentum is simply mass times velocity, or kilograms times meters per second. Okay? So the force times times is the impulse. That's the impulse that causes that change in momentum. Some examples of this: if I take a plate and I drop it on a concrete floor, it's going to shatter. If I take that same plate and drop it, it's going to have the same momentum, but if it hits a carpeted floor, it's probably not going to break. And that's because the time on there is going to be greater. It's going to actually absorb that plate a little bit as it sinks into the carpet, and though the change in overall momentum is the same, it's going to end up with zero momentum at the end. The amount of time it takes to stop it is reduced so the plate doesn't shatter. Same thing as if a person jumps out of a window into a swimming pool. Their momentum is the same and the water is going to stop their momentum. If they jump out of the same window onto a concrete sidewalk, their momentum is going to be stopped instantly. T is going to be very small as they're instantaneously stopped, and they're going to get hurt, right? They're really going to get hurt in that case. So that's an example of the same impulse, change in momentum, but because the time is different, it's going to affect the net force that's applied to change that impulse. Okay? Let's look at some examples of calculating an impulse and then using that impulse to calculate the change in momentum. Okay? I've got a force of 30 newtons exerted for 4 seconds on a 90 kilogram object. What's the impulse applied? Okay, so again, the change in momentum here equals force in newtons times time in seconds. Okay, and I've got 30 newtons times 4 seconds, and that's going to equal 120 newton seconds, which is the unit for an impulse. Okay, so if the impulse is 120 newton seconds, then that's also the change in momentum. Okay, so the change in momentum is the same, 120 newton seconds. Okay, so that's pretty straightforward. Now if I know the change in momentum, I can calculate the change in velocity, because remember, the momentum is the mass times the velocity. So if I say 120 newton seconds equals, in this case, 90 kilograms is the mass, and the velocity is what we're trying to solve for, v. Okay? So to simplify that, I can take my 90 kilogram v, divide it by 90 kilogram, and that's going to equal 120 newton seconds divided by 90 kilogram. Okay? Now the units here, remember, what is a newton? A newton is a mass applied over a distance, meters per second squared. Okay? So if I convert my newton to that, okay, notice I've got seconds squared over here, and I've got a second, so I can cancel that with one of those, and I can cancel my kilograms with that. I cancel out this unit completely, and my velocity here, whoops, wrong side, my velocity equals, again, 120 divided by 90, and then the only thing I have left here is meters per second. So 1.33 meters per second. So I've calculated the velocity based on the change in momentum. And that's how we can solve problems related to impulse.